sequences. Last three problems we're going to talk about as examples: 67, 75, and 91. So 67 is actually pretty easy. 2 minus 1/2 plus 1/8 minus plus So we're supposed to write this in summation notation. And if you look at that, we are indeed adding some stuff up. So sum equals from n equals, let's make this easy on ourselves, n equals 1. And what do we know? Well, we know that the first term is 2, and we know that we're multiplying by something. Now, I would argue we're probably multiplying by something. Well, let's figure this out. What is negative 1/2 divided by 2? Isn't it negative 1/4? So what is, so let's check that. That means that if I took 1/2 times negative 1/4, I should get, oops, negative 1/2, because that's negative 1/2. I should get 1/8. And do I? Hey, I do. That means that the constant ratio is negative 1/4 to the n minus 1. That would be the explicit formula for that. But here's the question. Where do I stop? In other words, when does that happen? So how do I solve that? Okay, so here's where the fun really begins. You could experiment with some numbers, right? You could recognize that 2, and then it goes 2, and then it goes 8, and then it's, well, all right, that could be tricky. So let's think about this. It means that 2 times negative 1/4 to the n minus 1 is going to equal 1 over 2048. Now, if I divide both sides by 2, then I get negative 1/4 to the n minus 1 equals, divide by 1 over 4096. Now, at this point, we've got an exponential equation that we're trying to solve, which means logarithms, but there's a problem. We've got a negative. We know the base can't be negative. So what we're going to do, because this ends up being positive too, right, is we're going to treat this as positive. Trust me, we'll be okay here. So what we're going to do is we're going to take the log of, so what's the base of the exponential? Why, that's right, 1/4. Remember, we're just treating it as positive for this case. So log base 1/4 of, well, 1 over 4096 equals the exponent, which happens to be n minus 1. So we're going to get a value here, and then we're going to have to add 1. So what is that value, you may ask? Well, when we do this out, it turns out that 4 to the 6th. So it turns out that n minus 1 is equal to 6, which means that n is equal to 7. Now, if we go way back up here, that means that we're taking the sum all the way up to, this is n equals 7. So that's our final answer. What looked pretty innocent turned out to be kind of complicated, particularly when we had to figure out the value. Other ways to go, well, you could keep multiplying by negative 1/4, right, and hope it doesn't take too long until you get negative 1 over 2, you get positive 1 over 2048. It isn't that bad either way. So find the sum of the geometric series if possible. If possible means is the absolute value of r less than 1, and in this case it is. So what do we do? Well, n equals 0. What is the first term when n equals 0? A sub 1 is 10. Why is that important? Because when we find s infinity, it's going to be a sub 1 over 1 minus r, which is 10 divided by 1 minus 0.11, which works out to be 11.236. I skipped straight to calculator. Did you watch that? So 9 plus 30 plus 10 plus 10/3. Determine if arithmetic or geometric. I'm going to tell you right now it's not geometric. Or sorry, it's not arithmetic. Find a common difference. So it doesn't have a common difference. That's arithmetic. Or ratio. 90 plus 30. So 30 divided by 90 is 1/3. 10 divided by, do you see what I'm doing? Is 1/3. So it turns out that, hey, r is 1/3. So the common ratio, r is equal to 1/3. If you write that down, people understand. sum of the first 15 terms would involve the first term times 1 minus 1/3 to the 15, because it's 15 terms, right? Over 1 minus 1/3, which is 2/3, by the way. And if you run the numbers, you get 135. Just be careful about your order of operations when you do run the numbers. These parentheses are there for a reason. That's where I advise Desmos above and beyond all else. And that should do it for you, for examples.